So I want to
What's
welcome every one of us to today's lecture and workshop. The way I believe we all enjoy ourselves in the first edition, and we are moving on to the second lecture today. And I believe this is going to be first lecture for R and on R programming. And I want us to please, if you have any question, quickly drop it in the chat so that the moderator for today, myself and Ogusaya, will quickly read it, and the facilitator will also help us out from there to put one or two solutions into it. So without wasting much of our time, I would like to welcome our faculty for today, Matthew Ekun, and he will be putting us through from there. So over to you, Ekun.
Good evening. You have issues with your double.
I think the best idea for us is, can you lower, are you okay now? Can you test your audio again?
Okay. Can you hear me now?
Yes.
Okay. Good evening. So today we are looking at the Arrow program. Arrow is one of the software that statisticians use these days, especially for data analysis, and other professionals are also using it. It's a popular language among the statisticians, but even non-statisticians also make use of it. So today we are going to look at some of the things we need in how to use R. So R is a language and environment for statistical computing and graphics. Sincerely, the first time I met it before I went to the University of Ibadan. But when I got there, I discovered that there is this software, that is a language for all statisticians. Though Python is there, but if you talk of R, it's what the statisticians are building on to make life easy. There are many other software like the S and S Plus, like SAS, but most of those softwares are paid for. But because of SAS is expensive and S Plus and S are expensive, we came up, some set of guys came up with this R. It's a language and it is free. It's a free software, so you can easily download it, install it, and make use of it. So we have Arrow provides a wide variety of statistical methodology like the linear and the non-linear model, the classical statistical tests like the ANOVA and cluster analysis and so on. It provides graphical techniques, and it is highly extensible. That is, users can play with it. How you want your graphic to look depends on the user. So one of our strengths is the ease with which well-designed publication quality plots can be produced, including mathematical symbols and formula where needed. There are defaults for the minor design choices, but the user still retain the full control on how it should look like. So you can compile, you can run on most of the OS, like the Unix platform. You can run on Windows and as well as on Mac. So it's very easy to install. There's a link that we sent on the platform. Once we click on the link, we can easily install Arrow from that link. It's not as difficult as the CQL that we learned, the SQL that we learned yesterday. Once you click on it, just be rest assured, follow the link, and you will get it installed. The two we need to install for now are the Arrow and the Arrow Studio. is the Arrow and the Arrow Studio. I believe most of us have installed it. I believe most of us have installed it, but if you have not installed it, you should just try to install it now. But those of us that are having issues, we should try and, those of us that are having issues, we should try and just make comments so that we can understand the issues we are having in installing it. But it's very easy to install. Next slide, please. So Arrow is an integrated suite of software Arrow is an integrated suite of software that facilitate data manipulation, calculation, and graphical display. It includes an effective data handling and storage facility. So you can actually use Arrow to store, make data to be storable in a database or in a spreadsheet. So you can easily manipulate from Arrow, manipulate data on any database. You can also use it to do most of the what you are going to learn from the SQL. Arrow can as well do it from your Arrow platform. You can actually write code to delete, to add, to manipulate data on the database or on any of the applications. So we also have a suite of operators for calculations on arrays, in particular matrices. As you can, we are going to look at that today, how we can work with vectors, how we can work with matrices, because data themselves are actually stored in vectors or as matrices. So we can use Arrow to store our data in vectors and in matrices. So a large, coherent, integrated collection of intermediate tools for data analysis. So we also look at graphical facilities for data analysis and display either on screen or on hard copy. So you can actually print direct from Arrow. A well-developed, simple and effective programming language, which includes conditionals like if-else statements. We can use it for loops, for for next statements, and for user-defined recursive functions and input and output facilities. So Arrow runs just like your Java, your C#, your C++. So you can use it as a programming language. You can use it as a statistical software. You can use it to even build your apps if you want to build apps, because it has other parts of it. Then let's look at the Arrow environment. The term environment is extended to characterize it as fully planned and coherent system, just the way we have your MATLAB, your Maple, and other softwares. So much of the system is self-written. It's written in Arrow dialect or X. So X is the main software from which we took Arrow from, which makes it very easy for users to follow the algorithm as the user places. For computationally intensive tasks, C, C++.
Welcome back to Nigeria. And so far tonight, Abraham.
And code at a runtime. So if you know how to use C or C++, you can actually use it to manipulate your program in Arrow. So many users think of Arrow as a statistics system, We prefer to think of it as an environment within which statistical techniques are implemented.
Make sure you include the hashtag.
So let's go to the next
I would
slide.
like to see it. Anyways, let's move on with the show right now. Please welcome to the stage, Sadie Henry.
Hello, please, Mr. Okay Samuel. Can you mute
My name
yourself?
is Stevie Henry. My first experience with the workout coach,
Let's go to
it
the
was
next
good.
slide.
She pointed out that I needed to work on articulation with some of the lyrics.
Sadie Henry is a cuddly baby. He has such a warm personality.
Hello, Mr. Okay Samuel. Can you mute yourself, please? Okay, Joe. Thank you.
Okay, let's go to the next slide. Mr. Musa, help me with the next slide.
Mr. Laro.
So now we are looking at how to download it. If you look at the download arrow 4.3.0 for Windows, you can just click on it. It's very easy to download. It will take you to a page. Then you see the different, you see the one for 64 bits, the one for 32 bits, and system. Depending on the system you are using, if you are using Mac, you see the one for Mac, just click it and download it. We only need 79 megabytes on the system for the installation. So you see the executable file. After you have downloaded, it's just a single file that will be downloaded. Click on it and install on your system. It's very easy to install. You can also choose the location you want to install it. If you have not installed it before, you pick a particular location and it will install it for you. So at this point, I want to know how many people that have installed it, or maybe we'll just give like 2 minutes for people to fully install the software, because I want to move to the console now so that I can begin to work.
Can I stop sharing?
And just stop sharing so that people can easily install. Let them install so that we know that they are all fully installed.
I think it's better we just put it on charts. If you know you've installed it, just say you've installed so that we can move on.
Once we get like 20 people, or let's say 50% already installed, we can just move on.
Yes, I installed it yesterday. Isaac. Yes, Samuel. Yes, Tosin. Okay, Abidogun. Jide. Ibrahim. Ayinde. Prof, okay. Oyeyemi, Femi. Fumi, yes. I think we can continue. People have installed, a lot of people have installed, except those people that have challenges with the installation. We can also guide. We can chat. So I think people have installed. Ekum?
Dr. Okay.
Yeah. We can hear you. Sir?
Use Matthew Ekum to connect me as a user so that I can.
Don't worry, you are connected.
The other one I was using was my phone, but I'm using the system now.
You are connected, don't worry. I can see he's coming in.
He's coming.
Yes.
Let me unmute myself.
Yeah, go.
Okay.
Can you hear me now?
I can hear you.
Okay, go ahead. So you want to share the slide by yourself now?
Yes, I want to share the slide. I'm no more using slide now. I want to use
Your laptop, the
my
script.
laptop.
Okay.
I want to use my laptop.
Then you can also launch your RStudio on your laptop so that you can follow.
Yes.
Yeah, that's what he's doing.
Over to you, sir.
Okay, sir.
Is there anything the matter?
Then I want to share the screen.
Okay.
Okay. Okay. Can you see the console?
Yeah.
Maybe I should. Okay, can you see the console?
Yes, you are visible.
I want some of the facilitators to answer me because now we're in an interactive class. So this is the R console. It's like a command line, just like you have your other software, your programming language that have their command line. So the console is nothing but a command line. We have the title bar, we have the menu bar. On the menu bar, we have the file, edit, view, mix, packages, Windows, help. Then if you see here, my cursor is blinking. That point is the command prompts. Whatever I type there is executing it line by line because Arrow is an interpreter. So once you hit enter, it will run that particular line. For instance, you can also use it as a calculator. For instance, I say 2 multiplied by 4. If I hit it, I have 8. If I say 2 raised to power 5, I have 32. So we use caret for power. We use asterisk for multiplication. We can say 45 divided by 9. Divided by 9, I have 5. So the / is for division. We can use SQRT 4. This is the square root of 2. You can also write 4 raised to power 0.5 to achieve the same thing. So you can say sine, for example, if you say sine 30, if you say sine 30, sine 30 will give you this. But if you put 30 in degrees, for you to put it in degree, you divide by 180 and multiply by pi so that it can give you 0.5. So all this, you can do that from your console as a calculator. You can also write a code from your console. But one thing about the console is that though you can save it and call it again, but you cannot distribute it. You cannot send it to somebody and distribute it the way so that if someone wants to replicate what you have done, it will be very difficult for that person to replicate. So that's why we are not going to dwell on the console. But if you have a calculation that you quickly want to do, maybe you want to find a sine or a cos, or want to find square root, or want to just write a simple formula, you can easily use your console. But if you want to write set of programs that you want to reuse, the best thing to do is to use the Arrow script. So I'm going to open the script I already have here, but I will teach you how to open a new script first. To open a new script, This is a practical class. I expect everybody to must have opened their console so that you follow what I'm doing. So you click on File, you click on New. Once you click on File and you click on New, you're already on a new script. So everything I've typed here, I can repeat them here. 2 times 4, 2 raised to power 5. Whatever I have written here, if I want to run a line, I'll just say Control plus R. That is 8. Control plus R, that is 32. So each time you want to run a code from your scripts, you have to use your combine button of the control key. You hold down the control key, then you press R, which will run. That is control like this. Then plus the arrow key. That is what you use. So just hold down the control key and you press R, it will run that particular line. If you want to run everything together, just select all and Control R will run everything for you. And the result will now come to the console. As you are running from the script, the results will come to the console. So the script, the code I have on the script, I can easily save it. The script is just like a notepad. I can easily save it or even copy it to a notepad and send it to somebody that doesn't have arrow, and the person you open it from the notepad. And if you have that, you can replicate what that person have done. You can adapt the code from the script directly. So that is the importance of using the script. Very soon, I will still take you to the studio, but I have some things I've written down. I'm going to open, I've downloaded it here. I'm going to open the script I have here. That is week 1. I know most of us already have this because I sent it on the platform. Let me close this other one. I don't need to save it. I just use it to show you example because you can actually save it. But at this point, we have our console and we have our scripts. So let's go together as I take you through how to manually enter raw data in R. If you want to enter raw data in R,
hello, sir.
Yes.
Hello, sir.
Yes, sir. I can hear you.
Okay. I think 1 or 2 persons is also requesting that we probably go over it again and in a slow version.
Is it the installation or what you have just done now?
Yes, the implementation of the code that you have used, you know.
Okay, so maybe we should do it this way. I'm actually supposed to start from this script, but I only use that console to show that they can use the console as a calculator. But from this script, I will take it gently so that they can follow it. But I can still go back to the console.
No, it's okay. It's okay.
I can, because everything I want to achieve from the console, I can actually achieve from the script.
All right, you can go ahead and make it a bit slower. Thank you, sir.
But can you hear my voice clearly? That is the most important aspect of it.
They are hearing you. They are hearing you. They confess that they are hearing you.
Can hear me. Okay. So if you look at this code, the hash I put there is showing that don't execute this line. This line is nothing but a statement, or what I call label or statement. So this line, how to manually enter raw data in R, will not be executed. You can only view it. You can only see it. Why we use comments? So that when somebody else wants to adapt the code, the person will see the comment, okay, what this code is actually for is for this. That's what comments are for, to guide you, so that you know that this particular code you are writing is for this particular thing. Because sometimes by the time I write the code, it might not be there, but the other users that want to use that same code, that want to adapt the code, they can actually see the reason you have written the code. So let's look at a vector. How do you enter a vector? The first thing we look at here is, if you look at my cursor, I want to enter numerical values. If you want to enter numerical values, what I have on my left-hand side, I have numeric dot values. That is a variable name that I've given myself. You can call it Matthew, you can call it Ade, you can call it anything, but there won't be space. You still respect the naming principle. Anytime you want to name a variable in any software, spaces are not allowed. You can use dots for arrow, also on I said underscore. You can use alphanumeric. You can use characters and alphabet and so on. Then what this implies, this does not mean equals to, in mathematics, when you say A is equals to B, it implies B is equals to A. But if I write A program, when you say A is equals to B, B inside A, that is as equals to side. In this case now, is the one receiving the vector. We are saying that this vector that is on the right-hand side should be assigned to the numeric dot values. The numeric dot values can just simply be X or Y or any variable name you want to give it. If you have been writing code before, it should not be new to you. Like those of you that use SPSS, you will see the name. And on that name, you can't put space. So you respect variable naming. So, but the what you have on the right-hand side is not just any code, it's arrow dedicated code. Like the C is for column. The vector we have here now, we have 1, we have 3, we have 5, we have 7, we have 9.
Hello, hello, hello. Yes.
Shane Bobby. Yes.
Yes, we can hear you now.
Hello, Mr. Ekun, we can't hear you again. No. Hello, is anything wrong with your system? Hello? Hello, Mr. Ekun. Can you also type yes if you can hear me? Because I'm not hearing you.
I can hear you, but
No, yeah. Mr. Ekun, please, can you type yes if you can hear me?
I can hear you, yes.
You can hear me. Okay, you are back. You about maybe like 3-4 minutes ago, we lost your voice, and maybe we just need to please go back a bit so that we can follow. Thank you, sir. Hello. Hello. Mr. Ekun, please. Oh God. Is it the network? Maybe check your this thing. Maybe you have muted yourself. Okay. Please, can you unmute yourself? Mr. Ekun, please. Hello? Is he even on? Matthew Ekun is talking, but okay, can you unmute yourself, please, Mr. Ekun? Check your system. Matthew Ekun, what's happening now? Please, can you please I don't know. Kindly let me get through to the facilitator and find out what is actually happening with.
Mr. August, can you please call Mr. Ekun on phone so that I can know what is going on?
Okay, thank you, sir.
Sorry, I just finished speaking with Mr. Matthew. He will be back shortly online. Okay, I think it's back now.
Chef, phone of his. Chef, phone of his. Okay. All right. So okay, I should just tell them that they should hold on. You are trying to change from phone to your machine. Okay. All right. Okay. I hope you guys. I'm sorry about that. He's trying to move from phone to was actually using his phone. The lecture caught up with him. He was actually on the road, so he needed to fulfill all righteousness. So he was doing the presentation while he was. So he got home. So he wants to change back to his machine. So let's just give him another 5 minutes to do that. We are sorry about that, please. Sorry for any inconvenience that you have caused. Please kindly just accept it. We are sorry about that. Thank you.
Sorry, Mr. Inga. I think Mr. Tope raised up his hand. Maybe he has a question. You can ask it, and why we use this period to answer the question.
Yeah. Okay, go ahead. You can unmute yourself. Though I didn't see any. Go ahead, Mr. You can unmute yourself and ask Mr. Tokwe or Mrs. Tokwe, whichever.
Sorry, I'm not having a question. I think that should be a mistake.
Okay. It's okay.
All
right, just give us like 5 minutes to sort out the changeover, okay, from the phone to laptop so that we can move on with what we are doing.
Let's connect. Let me share screen.
Okay, let me stop it first.
Let me share the screen now. I'm back.
All right, go ahead. You're welcome back.
Okay, I'm back. So I have the card dot values, that is cover that dot values. Not the same way as I've said before, the variable name is on the left, while the code actually I want to execute is on the right. If you look at the sign, I have two combinations here, less than, and dash, or less than and minus, whichever way you want to look at it. There are two things that form this backward arrow there. We have the less than and the dash. It's showing that we are assigning what you have on the right hand side to the left hand side. If you use equals to, you see achieve the same thing, meaning that what you have on the right hand side, you are assigning to what you have on the left hand side. But the direction of that arrow can also go the other way to show that whatever you have on the left hand side, you can as well assign it to what you have in the right hand side. So the direction of the arrow shows the assignment. So all what I have here is being assigned to what I have on the left hand side. So if you use equals to sign, you see I achieve the same thing. But the only difference is that if the arrow is facing the other side, then that means that, for example, if the arrow is facing this way, then that means that we are assigning what you have on the left hand side to the right hand side. So let's leave it the way it was. Then In the same way, if I want to look at the class of the vector, is it, what class of vector is this? If I run this, it will show character, meaning that the class of vectors, the values I have in that vector, they are what? Characters, not numbers. They are not numeric. And if I want to also locate a particular case from the vector or a particular observation from the vector, I just type the name of the variable, then use a square bracket. I want to look at the second element. If I do this, I'm getting Mike. It means that Mike is the second observation in that vector. We can use the following syntax to enter a data frame of a value in R. So let's create a data frame. We have score. The name of the data frame is score. So I have data.frame. So data.frame is a keyword. The score on the left-hand side can be anything. It can be X, it can be Q, it can be capital letter, it can be small letter, it can be alphanumeric. You can have this dots in between words or dash or underscore. So the keyword we have here is data dot numeric, and data frame is the keyword we have here, data dot frame. So we want to put the data in a frame, just like a table. So we have the name. I have Adam, Bensi. Those are the names. That is the first vector. I have under vector CA, which is 12, 15, 17, 24, 27. Then I have under vector exam, which is 40, 57, 47, 58, and 62. So I have 3 vectors, that data frame. So if I run this vector, this data frame, we can see the plus is showing because I entered on that line, a new line. That's why you have double plus there. The first plus is the first line, second plus is the second line. As I'm running it from the script, you are seeing the result in the console. So this is the score, the value of the score. The score is the data frame, and we have the name on the first column. We have CA on the second column, and we have exam on the third column. The first column is the name is character, why that is string, why the CA and exam they are numeric. If I want to look at the class of score, if I run this particular line, it's showing me that this class is data frame, meaning that it is not just numeric, it is not just character, but it's a data frame that combines different vectors. So you can view it as a matrix as well. So if you look at the data frame I have here, if I want to, for instance, if I want to look at the fourth rows and the fourth row and the third column, the fourth row and the third column, what is on the fourth row and the third column? Let me run it. 58. If you look at the first row, we have Ade on the first row. Second one is Adam. Third row is Bensi. The fourth row is Beatrice. If you now look at the first column, which is the name, the second column is the CA, and the third column is the exam. So I've actually picked 58. 58. So 58 is the value on the fourth row and the third column. Fourth row, third column gives me what? 58. If I want to look at the dimension of that data frame, I just do dim into score. Dim into score will give me 5 rows, 3 columns. That is the dimension of that data frame. Data frame is also seen as a matrix, just like your normal table. Let me put it that way. just like your normal table. So the table has 3 columns and 5 observations. So 5 rows and 3 columns. Then if, for instance, you want to look at the length of CA, you won't be able to get the length of CA from here directly. If I say the length of CA, it's saying object CA not found. Why is it saying object CA not found? Because CA is not seen as a variable declared. It is inside a data frame. We can actually look at score, but we cannot see the CA. You cannot get the length of the CA. Even if I want to call the CA, if I want to print the CA, it will tell you that CA not found, because CA is not standing alone. CA is inside score. So what do we do? What do I do to get CA? If I want to get CA, I have to type score, then $CA. With this, is saying the CA. So I can actually look at the length of this now. Length of this, and the length is 5. That's the size of the vector CA. So I put score $CA because score is the actual data that we have, the actual data frame. But CA is a vector in that data frame. It's just a column. It's just a vector in that data frame. So that's why I have to do score $CA. Because very soon, by the time you start bringing in your data, you name that data you are bringing in. Maybe you are importing the data from Excel or from any other database. You will name that data you are importing with a particular name, just the way we have the data frame. And if you want to now assign a particular variable in that, on that table, you have to do the same thing, score $CA to get it. But if you define CA from onset, you can easily get your CA. We'll get to that very soon. So the length of score $CA is what? 5. That is the length of that vector. Irrespective of the length of the vector, it will give you the length. The length is like the size, the number of observations. Number of observations is 5 for CA. Then we should note a matrix requires each column to be the same type, unlike data frame. Now, that is the major difference between a matrix and a data frame. So a data frame is just like a table. Just take it, table can have different columns, and each columns are not necessary to have the same, they are not necessary to have the same type. A particular column can be for name, another column can be for numbers, another column can be for dates, another column can be for email addresses, another column can be for pictures, and so on. But in a matrix is a collection of items, numbers that are alike. Yes, if you have numbers, then it means that everything in that matrix are numbers. You don't mix numbers and this together in a matrix, it will not take it. So that's just the major difference between a matrix and a data frame or a table. So we can use the following syntax to enter a matrix in R. So let's create matrix with 2 columns and 5 rows. Look at this one. I have CA. Now CA is not under any table. So I'm the one that entered this CA myself. CA, I have 12, 15, 17, 24, and 27. And also have exam in the same vein. So now I'm the one that want to bind both CA and exam into a data frame. I will now use this code. We call it C bind, column bind. If I run it, so CA and exam, they are two different vectors. I've now binded them into math. So I will use C bind, CA, comma, exam. So if I want to display the math, so you can see I have CA, I have exam. Now, if I want to print CA alone, I can easily print CA. You can see the values of CA. Unlike the other CA that I couldn't print directly because it was not declared as a variable standing alone. It was inside a data frame. The same thing with the exam. I can easily print the word exam, just the way I've printed the CA. So let us now look at row 4, column 2. If you look at the data value in row 4, column 2, you have 58. So just like the data frame, you can easily cite any value within the matrix. So you can easily locate a particular value in a data frame or in a matrix. So the dimension of a matrix and a data frame, they work alike. So at this point, before we continue, let me just show you some of the things you need to know, because the training we are doing now is just to give you the basics you know in R or in any of the software we are learning. But you need to know how on your own, how you can get help. One of the ways to get help is to type help.stat and you open and put in the open bracket and the close brackets. If you run this, it will take you to a window. It is free. You don't need to have data to do that. You can see it's taking me to the manual. From the manual, I can move to anywhere. If I want to look at an introduction to R, I can do that. So whichever thing I want to do from here, I can do them from this place. So let me close this. Then we can also look at log. I want to look at log. How do we use log? I can say help, then put log inside the brackets. This has taken me to log. I can actually look at log S, then the base. If I don't want, you can just quickly go down. You always see example at the end. Look at example. This is log exponential 3. This is log to the base of 10 of this value. So if you just have log, this is log to the base of E. That is the natural log. But if you have log 10, it means that this is the log to the base of 10. You can have log 2, means that it's log to the base of 2. If you have log 5, it means that it's 5 and log to the base of 5. Then the value you are looking for the log will be inside the brackets. And once you run it, you will get the values for the log. So this is help for log. If you want to get log. Another way to look at get help. Another way to get help is to type apropos log. Put the log inside double quotes. You will get help. If you want to get example for log, also run this one. You will see examples on how to use log. So you have seen different type of ways to use log. We have it here. These are some of the examples of log. Yes. You can also use, look at this. If I put double question mark before log, I'm looking for log. How do I use log? How do they use log in R? You don't know. I'm using log as example. It can be anything. It can be anything you want to get that. How do I use this particular, how do I look for the, maybe you want to look at matrices, you want to look at linear model, you want to look at chi-square, you want to look at normal. that how do we use it in R? So just use your double question mark and log. It will show you how you can use it. You can see this. This has given me many ways I can use log. So with this, you now look for the particular, you can see log likelihood. Anything log, it will give you. But if you want to now be specific that it's not everything about log, I need log itself, just put one question mark. And by the time you run this, you can see that the result I get here is the same result as that of help log. So you can see the values there, the examples. Anytime you come to this page, just go down, you see examples. But if you actually want to know it, then you can now read through each of the things you have there. You can now read through each of the things you have here, but this you can do on your own without the help of anybody. So let's continue. Now, we want to look at the objects we have. We have different objects in the console now. We can call those objects you have on the console using objects, this line, objects, open bracket, close brackets. You can see we have CA. The second CA will override the first CA. We have car.values, we have exam, we have maths, we have numeric.values, we have score, we have X. These are the variables you have created or the objects you have created so far. Some of them are variables, some of them are the vectors are the variables, some of them are data frames, some of them are matrices. So these are all the objects you have. You can use lists. You can use this one, ls, it will still give you the same result. You can see. So two ways of doing this. You can just type objects, open and close brackets. You can still type ls, open and close brackets. You get the same result. Then if you want to remove a particular object, you use remove CA. Instead of typing remove completely, you just type RMCA. If I run this code, it means that I've taken away CA from all the objects you have here. You know, here we have CA, car values, exam, maths, numeric.values, score, and X. If I go back and say list all the variables, you can see there is no more CA because I've removed CA from the console. So it does not have any memory of CA again. If I have CA here and say, let me print CA, object CA not found. Object CA not found because I've removed CA. It's not seeing CA again. Then to now clear the whole screen, different languages, we have different ways to clear screen. But if you want to type it as a code, you use remove list. If you type this code and you run it, it will clear everything. Everything is already cleared. So by the time you go back and run this ls, you will not see anything. It means that everything we have above are no more there. Then we now look at how to quit. You can just type Q, open brackets, and you quit arrow completely. But I don't want us to quit now. You can quit and come back, but because I'm the one doing the training, I don't want to quit. So you can quit from this. You can type it directly from the command point. You can quit from this place. And no ordinary, if you want to quit, you can just close, save, close everything. But if you want to quit from the command line, you can do that using this command Q, using this code Q, open bracket and close brackets. Now, let's look at generating data. Generating data. The first thing we have looked at is you are the one entering the data yourself. You have the data somewhere. I just want to enter it manually. You enter the data manually yourself. Maybe you have student score, you have their exam score, and you want to calculate their CGPA. You know, you have it in hard copy. You have to type it just the way you have typed the other ones. And you can do the total. Okay, let me quickly go back and show you that. Maybe like, let me go back to that CA and exam. Let me just show you little manipulation before we go far. We have, if you look at this place, the last, okay, here, let me do it again because the CA and the exam are no more on the console. This is the CA, this is the exam. I can decide to look for total. Let me say total. Let me just put total, or let me type total fully, capital letter. I want to add CA and exam. There is no big D in ours. Just type CA plus exam. If I run this, it is not running because the exam is written in capital letters. So let me just write it the same way it is there because it is case sensitive. So I've done that. Total equals to CA plus exam. If I want to now see the values of the total, I cannot go, it's dangerous to type, just copy and paste so that you not type something else. If you do this, it will print out the values of the total. So you can do anything with the combination of anything you want to do there. Even if you want to multiply it, it will multiply it. If you do the not matrix multiplication now, there is a different way we do matrix multiplication. But if you just do your normal multiplication, it will multiply it case by case. It will take the first observation, multiply with the first observation in the first column, multiply by the second column, and the first observation, the first variable, multiply by the first observation, the first variable, the second observation is the second variable with that of the first one, and so on. So just normal listwise multiplication, just the same way he has done the what addition. So with this, you can do whatever you want to do with the values and look at the total. If you know how to calculate the GPA, CGPA, you can calculate it. If you have the unit grade points for each of the subjects, you can actually do that. So let's go to where we are, where we were. Okay, generating data. As I said before, the first one, we enter the data ourselves. Now, we want to use code to generate data for ourselves. The first one is regular sequence. What are regular sequence? Numbers like your AP, your GP, they are regular sequence. Values that you don't need any prophet to tell you what the next value will be. If I say 2, 4, 6, 8, that you should complete the rest, you know that the next one will be 10, 12, 14, 16. Those are regular sequence. If someone tell you that if you have values 2, 4, 6, 8, 10, and somebody not told you that the next one will be 12, you say my prophet is prophesying. He's not prophesying anything. It's a common sense to know that the next one will be 12 and the next one will be what? 14. and so on. So such values vectors are called regular sequence. For instance, I want to generate numbers from 1 to 30. Just simple assignments. X is the variable name now. This is my code. 1 column 30 will just generate the values from 1 to 30, and that's all. And I can print that. These are the values 1 to 30. It's as simple as that. Instead of typing C, open bracket, and start typing 1 to 30, you can use this to generate numbers from 1 to 30. The resulting vector S has 30 elements, 30 observations. So if, okay, the operator column has priority on the arithmetic, just the way we have bracket. If you look at BODMAS, we have to execute the bracket before the addition and the subtraction, or before even anything. In the same way, the column, this column here has to be executed before the arithmetic operation. For example, if I run 1 column 10 minus 1, it will not do 10 minus 1 first. It will do 1 column 10 before the minus 1, and it will shift everything by 1 backward. Instead of me having 1 to 10, I will have 0 to 9. Let's run it and see. You can see I still have 10 values, but instead of me starting from 1 to 10, I have 0 to 9. But if I put 1 column 10, I will have 1 to 10. I have 1 to 10. Then if I now put brackets now, so the bracket now will now precede the column, because the bracket must be executed first. This one is the same thing as saying 1 column 9. Let's run this and see how it looks. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can see that the 10 minus 1 here is executed because there's a bracket where we have the 10 minus 1. Like the first one, we just have 10 minus 1. So the column will precede that. Will be seen before the 10 minus 1. So the function, we have another function, sequence. Sequence can generate real values or numbers. If we have sequence 1, 5, 0.5, what sequence 1, 5, 0.5 will do, we want to generate values from 1 to 5 with step 0.5. The mesh size or the step, which is 0.5, means that if the first one is 1, you add 0.5 to it, or what simply I can say the common difference. The common difference is 0.5. So if I run this, I have 1, I have 1.5, I have 2, I have 2.5. So the common difference here is that 0.5. The minimum is 1, the maximum is 5. So if you use sequence, minimum 1, maximum 5, and the common difference is 0.5, or the interval. So I've explained that here with the comment I have here, where the first number indicates the start of the sequence, the second number indicates the end of the sequence, and the third number indicates the increment, which I call the common difference or the mesh size. Okay, one can also use length. If you use it this way, then you can interchange it. Since you are already defining it that length should be 9, then it should start from 1 and end at 5. In this case, you are letting us know that we need a vector with 9 data points. starting from 1 to 5. So arrow knows how to now demarcate it in such a way that they will have equal interval, equal size. They will have equal increments. So if I do this, what I have here is not different from what I have here, but I've written it in two different ways. In this second one, I just needed it to be 9. I needed 9 values. And it should start from 1 to 5, which is the same thing as this one. In this case, the first one we did, we don't know the length, but we know that we are starting from 1 to 5 with an increment of 0.5. But in this case, the second one, we don't know the increments, but we know that we are starting from 1 to 5, but the data point should not be more than 9, should be 9. So if you do this, you have the same result with this. But if I change the length to 10, if I change the length to 10 and run it, you can see that I have 10 values. I have 10 values starting from 1 and ending at 5. Let me take this here so that I can see the other values. So starting from 1 and ending at 5. So let's go. It is also possible to type directly the values using the function C, as you have done before. So that is the third way of getting the sequence, but that we have already learned it before on how to enter data directly. Now,
hello, sir. Ekum.
Hello, can you hear me?
I can hear you. Can you also hear me now?
I can hear you, sir.
Okay, thank you so much for how far you've gone, and we really appreciate that. Can we please expose our audience to RStudio too?
Okay.
Because console, you and I know that if you are not a coder, programmer, it's a bit, difficult, but you can show them the way they can use it on RStudio, which all of us were used to. Thank you, sir.
Okay. Okay. So everything we have done here, we can also repeat it.
Exactly.
On the RStudio. Let me just copy everything I have here. I can take it to RStudio. So let me stop sharing this. I will still share my. Let me share the RStudio. It's like I've already opened it. Okay. Okay. Share. Let me have a new. Let me open it. Okay, before I open a new one, if you look at the RStudio, we have 4 environments there. We have the first environment where we have the scripts. We have the other environments here where we have the console. So from the console, you can as well. Can you see my screen now?
Yes,
hello.
sir.
You can see the RStudio. So you can also open your RStudio. You can also open your RStudio. Let me open a new script, and new file, scripts. Okay, let me just quickly take some time to explain. Can you see my screen, please?
Yes, sir.
Okay. Let me quickly use some time to explain this new file. If you look at under the RStudio, the new file is not only the RS script that you have on the new file, from the new file. You have many other things, meaning that you can go to any of them and use. If you know how to use our notebook, you can go there. If you know how to use Markdown, you can go there. If you know how to use Shiny Web App, you can go there. Shiny Web App, you can use it to design different apps that you can use. If you know how to use C or C++, you can go there, CSS file and cascading style JavaScript, Python, the SQL scripts, and so on. So from here, you can actually click the particular environments you want to go. So I'm interested in the Arrow script. I'll just go to the Arrow script. This is the new one. The one you are seeing before was the one I've actually used. I've copied all my code, all the code I have in Arrow. I've copied to the studio. All the codes are here now. Okay, now I'm working from the studio. What the advantage the studio has over Arrow script is that from the studio, as you are typing to be suggesting, it's very smart. It will suggest whatever you want to type, even if it's a variable name, it will suggest the variable name you want to type. So it makes encoding very easy for those people that are forgetful, or they are not code friendly. By the time you use work from the studio, it will help you. Like, for example, I want to type numeric dot. You can see it's suggesting for me numeric dot. Is it numeric underscore version, or numeric derivative, or numeric, just numeric, or numeric dot values? So just enter or click numeric dot values. You have your numeric dot values. But if you are running from the script from the studio, it's not the same control plus Arrow that we run it. If we look at my cursor, can you see my cursor? You see run there. If I want to run this numeric dot values, if I click on it, it will run it. If I click on this, it will run it. If I want to run everything, I'll just select all and run everything. Everything will run. So let me go down to where we stop, so that we will not repeat everything we have done before. But now we are working from the Arrow Studio. And before we end today, I will also take you to the Markdown, so that you see how to also use the Markdown. Just help me look at time, and Dr. Okay, once it's like 15 minutes too, so that I can switch to Markdown, so that I can also explain how to use Arrow Markdown. I've done replicates. Okay, let's look at sequence. How does sequence work? Sequence 4:5. The function sequence creates series of sequences of integers, each ending by the numbers given as arguments. We have 4:5. It has given me 1, 2, 3, 4, and it has given me 1, 2, 3, 4, 5. So that is how sequence work. So if I run this sequence 10:5, if I run this, you can see the values I'm having here. I have 1 to 10 and 1 to 5. So that is how to use sequence. So now another way to generate sequence of number is to use the GL. If we look at this function is very useful because it generates regular series of factor value variables. The uses of this function is GL k, n. So if you look at this, if you run this, it has, if you run this, you can see it generated 111, 222, and 333. So the levels we have there are just 1, 2, 3 levels. We have how many levels there? 3 levels. If you run this one to also have 3 levels. 111, 222, 333, then 111, 222, 333. So all these are different ways of generating sequence of numbers. Let me go down to the random sequence before I move to the markdown. Okay, let us also look at grid. If you run how to use grid, if you look at this expand.grid, these are the values generated using expand.grid. You have the age, the sequence 60, 80, 10. Then we have the W and we have the sex. So it has generated the sequence of values. So these are sequence. So let us now go to random sequence. Random sequence means that the numbers are randomly generated. They are not numbers you can easily guess. In fact, if you have the first 2 numbers, to get the third number, it's only God that can decide what the third number will be, because it is probability. It is random. And anything that has to do with randomness or that has to do with probability must follow a particular distribution. It could be uniform distribution, it could be normal, it could be exponential. It must just follow a particular distribution. For those of us that are statisticians, random numbers are not new to us. For those people that are non-statisticians, there are some numbers we call random numbers because we generate them using random experiments. For instance, you want to toss coin, you know the possible outcome that they are either head or tail. But how you generate them, because you generate them randomly, you don't know what the outcome will be. The particular outcome will be before the event. But you know the possible outcome that yes, you have head tail. So you can have head. Because you have head, it's not an assurance that the next one will be head. You can become tail. So that is why it is random. If you have a die and you want to throw it, or you want to throw the die, it has 6 sides. So the number that will show up on the die cannot be known by man until after the experiments. But we know that we have 6 possible outcomes. So these are random numbers. If you are looking at ages of university students, it's also random because they do not have the same ages all through. Some could be 16, 19, 21, 25. We also call that random numbers. Our data generally are random, provided they are not constant values or they are not a sequence of numbers as you have seen before, just sequence. But when you say random sequence or random numbers, you are talking of those numbers that you cannot predict them except using a particular distribution. So any data you have collected and stored, each of the variables has a particular distribution they follow. So the first thing you do is to look at the distribution of that data. But let me not take you far so that I'll not take you to distributions. Let's quickly go back to where we are. Now let's look at the distributions we have in R. These are the ones we have. You can also generate your own. We have the Gaussian, which is the normal. If you want to run it, just use R normal to run it. Each distribution you pick, let's start with the first one here. We have R norm. We want to generate random numbers that are normally distributed, which means 0 and standard deviation 1. So it means that the numbers that will be generated, we have a mean 0, mean that it can be greater than 0 or less than 0 with the spread of 1, with the standard deviation of 1. Then the n you are seeing there is the number of observations you want to generate, or the number of values in the random number you want to generate. So it means that for you to use any random number, you must know the parameters that that distribution has. Like for normal, it has mean and standard deviation. That means S is normally distributed with mean and standard deviation, meaning that if you know the mean and you know the standard deviation, you can generate numbers, random numbers using normal distribution. For exponential, exponential only has one parameter. That is the rate parameter. So once you know the rate parameter, you can generate using exponential distribution. If you want to generate using gamma, that is arrow gamma. Look at it. Exponential is arrow ESP. Gamma is arrow gamma. You have to know two parameters, the shape and the scale parameters. If you want to do random variables using Poisson distribution, is arrow poise. You must also know the parameter of that Poisson. Poisson too also has one parameter, which is lambda. You can write n equals to lambda equals to, or just type 20,5. 20 arrow points 20,5 will give you 20 observations, 20 numbers, but with lambda as equals to what? 5. That is the mean. No Poisson, the mean is equals to the variance. So the mean is 5. So if you want to do for Weibull, is arrow Weibull. Weibull also have shape and scale parameter. If you want to do for Cauchy, is arrow Cauchy. We have location and scale parameter. For beta is arrow beta. We have shape. Beta has 2 shape parameters. Then for student T has 1 parameter, which is the degree of freedom. For F has 2 parameters, the degree of freedom of the numerator and the degree of freedom of the denominator. Chi-square, that is Pearson chi-square, has just like T, also has only 1 parameter, which is the degrees of freedom. Then for binomial is arrow binom. Arrow binom have 2 parameters, the size and the probability. That's why we always talk of the mean to be NP. So once you know the size and the constant probability of success, you can always use your arrow binom. Then for geometric distribution, you have 1 parameter as well, which is just the probability. So it's arrow geom. For hypergeometric distribution, we have arrow hyper. We have the M, N, and K. And the NN, you know, it has to do with combination. Then we have the logistic, arrow logis. It has a location and a scale parameter, which you must know before you can use it. You have the log normal. That is, look at this log normal. It's arrow L norm. Normal is just arrow norm, but log normal is arrow L norm. So there is L there to differentiate it from that of normal, because normal too also has a location parameter and a deviation, which is standard deviation, but this one is mean log and mean. So it's the same thing. If you want to write it, for example, if you want to write this, let me quickly do this here. Permit me to do this here. If you do this, let me take away the comments. Okay, the comment is not there. If you do this and I simply put 5 here. Let me not use too much numbers. I put 5 and I run this. It has generated 5 numbers for me. And these are the random numbers. You can see that they are actually random. They are not all like the other sequence whereby if you have the first number, second number, you'll be able to know the third, fourth, and fifth. But in this case, the numbers are random and they are generated from what? From log normal distribution. But if this for normal, I'll just have, I don't know.
You have 10 minutes to go.
Okay. If this for normal, I'll just have, I don't know. I'll put the 5. That is the observation I have. I can put 0 as well and 1. If I run this, it's just telling me that my n number of observation is 5, the mean is 0, and the standard deviation is 1. If I run this, okay, sorry, 5. If I run this, the n equals to 5. The mean equals to 0, and the standard deviation SD equals to 1. So this will give me, the one I have below is normal distribution, meaning that the values are generated using Gaussian. The first one is log normal, the second one is Gaussian. So for every other distribution we have there, just if you want to run any of them, just copy the code. The code did not start from this place. The code starts from after the column. You just copy it. For negative binomial, that is for that. If you want to do for recursion, for uniform distribution, for recursion, and we have all that there. So I also have many other code below, but the assignment I will give to you is to go and run all those code. Some of the ones I have under here, I did not separate them. So I copied both comments and the code. So what you have to do, like in this case, notes, you put hash in front of each to make it comment, put hash in front of it to make it comment. This one, you take away the greater than sign and you run it. I just want to see how you can run those code on your own at home. But before I end the class, I can convert this arrow script to Markdown. I can go and look at this arrow Markdown. If I put arrow Markdown there, let me go down. I want to convert it to Markdown. Control. So for Markdown, just if you put, go to this place, if you see what I have here, you see arrow Markdown there. Click arrow Markdown. Once you're on the Markdown, just type, hold the control down and the Alt and I. It will give you this. You can also type it manually. So if I want to do, for example, sequence, some of those things you have done before, sequence 1:5. if I run this, you can see the way it looks like. It looks as if you are using your Spider or your Jupyter to run your Python. It will run and produce the result just immediately. If I want to run this this particular code that I have here, and I want to use Markdown to run it, I'll just type Ctrl-Alt-I. I'll paste it there, run it. You can see the results. The result shows in the console, but you also show immediately after the lines of code you have, meaning that all the lines of code within that block, I can actually run it. I can take them chunk by chunk. So I have the first block here, which I can run this one. I have the second block here. I don't need to select them. Once I run it, it is run all the lines of code within that chunk, within that particular block. So any code you want to write using your Markdown, just do your Ctrl-Alt, then you press your I key. It will give you something you want to work with. Maybe you have want to calculate the area of a cycle. You need to know the radius of the cycle. Let's say R equals to 4. You can say I'm using equals to. You can use equals to direct. It will still give you the same value. Then the area of a cycle is z by r squared now. Pi multiplied by r squared. If I run this, okay, let me print out the area of the cycle. If I run this particular chunk, it will give me the area of the cycle. So this Markdown, you can actually use it in place of your it's still the same thing from your studio, but it will only help you to get the result in bit by bit instead of just running all the lines of code at the same time. You can run it this particular set, you get this particular result. You run the next set of results, you get it. And another good thing about the Markdown is that if you know how to use it, you can write a complete lecture material from the Markdown that you can open from your HTML, you can open from your PDF, and it will look very smart. So at least for now, just know that you can actually run some set of code with the Markdown. Let me leave time for questions so that by the time we come back in next class, that is next week, we now look at how to bring data from other sources. Major thing we have achieved today is to enter data ourselves, generate sequence of values, generate random values, and manipulate the data. So with what you can also locate vector. If you have a table, I want to locate a particular vector, a particular column, or a particular element from that table, you can, or from a matrix, you can easily locate that. And if you want to manipulate, do many things on, you can actually do that with what you have learned today. And you can also write simple formula like the one I've written now. And you can run it and get your result. So by the time we come next week, we look at two things majorly: how to bring in data from other sources, how to do plots, your bar chart, your pie charts, your histogram, both charts and graphs, with and other diagrams. We teach you how to generate them, how to write code for them, and how to adapt existing code. Then I also look at some data analysis, maybe like your linear model, your GLM, that generalized linear model, your ANOVA, t-test, chi-square, and maybe as many as you can do for your data analysis. If you have data and you want to analyze it, you can actually use R to analyze your data. Let me allow Dr. Oke to come in at this point so that we begin to ask questions. If you have questions, let me see if I can go to the comment section. Let me reduce this and see if I can go to the comment section. Dr. Oke, are you there?
Are you
What of
true?
I'm
Yes, I'm
true
here.
for today's lecture.
All right.
So
Thank you
let
so
us
much.
let us give chance for
Ekun,
questions.
and we put our hands together for our facilitator for tonight. Want to believe that he has assisted us introduce the concept of R, the windows, both the console and the studio, and the background of R also were introduced
and
to
the markdown.
And the markdown. Okay. So if you have any question for him before we call it a day, please send in your question so that he can address it once and for all. And all right. So Mr. Ekun, they say thank you. They are appreciating you for what you have done so far. All right. So if you have any question for him, let's throw it to him. If you have any difficulty in any area, the next 5-7 minutes, we can come up with those questions. Okay, Mr. Ekun, thank you so much. Thank you so much.
I'm going.
Okay, no, are we saying there's no question for him? You are okay, you are satisfied with what you have gotten today. So we need 1 or 2 persons to just summarize what you have done today, at least to show that we have made our day for today. Who is going to volunteer to speak for the class? What we have gained today? Hello, you can unmute yourself and speak. You are free at this moment. You are free to talk. Okay. So if there's no question for him, if there's no contribution, I want to believe that our silence means that we are okay with this lecture for today. Once again, we want to apologize for that short break in transmission and the inconvenience that it might have caused one or 2 persons on the platform. We are sorry. It is not in our tradition. It was just because 1 or 2 things that happened. Okay. So in preparing ourselves for next week, I pray the Lord will keep us till next week. By the special grace of God, Saturday, he will continue the series of the SQL. And on Sunday too, we will follow up with the R. So let's get ourselves ready, as many materials that we can read before the class. As many material we can read before the class. So let's do that. Hopefully the SQL class is going to take us like 4 weeks and 1 week project or question and answer interactions. Likewise for R. So thank you so much. If there's no question, you can call it a day if there's no question for Mr. Ekun. So we'll see you next week by the special grace of God, 7 o'clock for Mr. Babatunde SQL. Thank you, and God bless you all.
Thank you so much.
Right. Thank you so much, sir. Really appreciate
Thank
it.
you, thank you, Mr. Ekun. Thank you.
I really enjoy.
Thank you. We appreciate.
Thank you so
All
much,
right,
sir.
Thank you.
Thank you so much. Good night.
Good night. Thank
Good
you.
Amaka. Good evening. Thank you.
Don't call. Good night. Good evening.
Sylvia.
Sylvia. Sylvia.
I'm here.
Sylvia.
All right. All right.
Thank you so much. Thank you so
You
much.
can see your face.
Okay.
Ah,
So if you have any additional message, I mean, you want to tell us what you want us to improve on, you can private chat us, you know, or you go to you can send your message to Ekum, or you go to let me send it to, you can go to Data Mind, send a mail to us. We'll be glad to respond to any contributions you have for us. Okay, we'll be
Thank
glad
you very much.
So,
thank you.
Okay, so you can send a mail to us, and
Okay.
we'll be glad to respond and to correct all the probably there's one or two things you want us to correct. Please kindly send it to that mail. All of us are learning, we're improving ourselves. Thank you. Good night, sir.
Okay, can we pop it on the WhatsApp chat? We didn't really.
Yes.
Okay, thank you.
Okay, we'll do that. We'll do that.
Okay, take care. Bye.
Good night, sir. Good night, all.
Good night.
Good night.
So, yes, we're gonna be like this.
You still there or no? Okay. Wow, it's a nice one. Week one has gone, so we have 7 weeks to go. This man, what is this man appearing for? How for you?
In fact, because my pastor, they nearly put me with
So, yeah, this man go and sleep. Let me leave here.
Okay, everybody has gone.
No, everybody is still there. So hello, Dr. Julius is there. Dr. Aide is there. So
okay,
people are still there, but I don't think there's anything you want to say that this man, go and read your book. Your father is doing something.
Ekum, thank you. Ekum, thank you. This is Adeyanju.
Adeyanju Isaac. I salute you.
Thank you so much. We appreciate it.
In fact, today I went for Holy Communion. I nearly missed the class. So I started with my phone, so I had to switch over to the system.
Thank you for your time. Thank you. We appreciate it.
Okay, please add.
I'll be looking for.
I hope Sheriff to call on the platform.
Tani.
Sheriff, let me send this number.
Okay, Sheriff, what's the crew? We only have
somebody send
10 people left.
Yeah, somebody send a number. Let's take care of the number quickly so that.
Okay. Ask Mr. Gusa. Those people that are joining should also register online. That is using the platform. The link.
Yes, we said it, but
you know that some people that have just added to the WhatsApp platform that has not registered. Directly, they've not registered.
Okay.
How many participants do you have today?
We have 51.
51, that is good. It's an improvement now to what we had yesterday.
Yes, yesterday was 46.
Okay. So I know by next week it will be more than that.
Yes, hopefully. You know, some people are actually coming in and work on Jade, talk on Wale. So I wrote down, I took attendance. So for those that
Okay, today.
yeah, yes.
You actually wrote down the names.
Yes, I wrote down their names. Yes, now to confirm the attendance is also very important. At a particular point,
Okay. My video is still on.
Yeah, we still have about 9 people on the platform. You know, the man to Yakopa. Let me check my profile first. So by mini host then I can put it on.
Okay.
Okay,
Dr. Gad, Dr. Ken is still there now. Okay,
it's still
there, Dr.
but it's not, I don't think it's available. Who is Ogunsoya Adeyinka Abiodun? Hello, sir.
This is Mr. Gusa. You don't know your namesake.
I don't know him. Hello, sir. Ogunsoya Adeyinka.
Sir, Abima.
Ma, okay. Okay. Which my namesake?
Hello.
Hello, ma.
Ẹ kú gbádùn o.
Ẹ kú gbádùn.